Okay, this should be a pretty short video. We are just going to talk about a little bit more with factoring polynomials. Yesterday's video was on factoring polynomial expressions, and today these are polynomial equations. So you'll notice the information that is in this upper box here is the same information that was on the notes page in the previous video. It is crucial that your initial step is to make sure that it's in descending order, that the lead coefficient is positive, and very, very important that we are definitely checking for that GCF before we are moving on to see whether our problem fits into one of the following types of factoring problems that we have here in our list, okay? The added step, if you recall when we did this with quadratics, is when the problem then is an equation versus an expression, at the end of the problem you would then set any of the factors that have variables in them equal to 0. So I'm just going to make that small adjustment to the one problem at the bottom that I worked out. I shouldn't have boxed the answer in that I have boxed here. You can see all of these are equations, and so the idea is, as referenced in the directions, it wants us to solve each polynomial equation by factoring. So in the end, we should be saying things like x equals such and such a number. Okay, you'll notice in this example here, I identified this as being a difference of 2 cubes. And once I factored it, I should have set these factors equal to 0. So what you're going to do, and if you recall from the previous video, we said that the trinomials cannot be factored any further. So you will not be able to do anything more with this trinomial. The answer will strictly come from you setting just that binomial factor equal to 0, and then you will solve for x. So the answer to letter C is that x equals 5. Okay. It is important, though, since the directions are asking you to do this process by factoring, that you have shown this step, and then you can go down to your answer, but you should show how that difference of 2 cubes looks in its factored state. Okay, we are going to skip letter A. We're going to move on here to part B, and I'm going to try to keep what's in this box visible so that we can reference that our initial step here is checking for descending order. Our lead coefficient, the 54, is positive, and then we want to definitely check for that GCF. Okay, so if you recall here, it looks like probably 6 is going to go into both 54 and 24, so I'm going to divide both of those by 6, and that leaves me with 9x squared minus 4. Okay, and then I'm going to examine this 9x squared minus 4 and see where I think it falls here. Again, if you recall from the previous video, these types are binomials, and these types are 3 terms or more if you're talking about this last type here. Okay, so 9x squared minus 4 is definitely a binomial. Okay, I see that it's got subtraction here, so that's going to eliminate. It's not going to be a sum. I'm down to either this is a difference of 2 squares or a difference of 2 cubes, and if it's neither of those, then it was this initial type, which is where I was able to take out the GCF, but then I couldn't do anything more. I'm looking at the numbers 9 and 4. I'm going to say, you know what, those feel like those are perfect squares. I'm going to look at the variable, look at what the exponent is on that variable. It's an even exponent. That means the variable is also a perfect square. So it's feeling like this is a difference of 2 squares. Again, you don't have to identify the type. I'm just doing that here for the notes. Okay, you want to keep the GCF there in front. Okay, remember our way of factoring a difference of 2 squares is to create 2 parentheses. We're going to put a plus in the middle of one, minus in the middle of the other. We're then going to take the square root of each term. Square root of the first term is 3x. That should go in the first spot. And then square root of the second term, that's 2, that should go in the second spot. Now, if this was just an expression, we would stop right here. But since this is an equation and they're asking us to solve this by factoring, we would then proceed by taking each factor that has a variable in it. Okay, so we're not doing actually anything with the 6, although the 6 should be right out here in front. You don't want to lose that. Okay, I'm going to set each of those factors equal to 0, and I'm going to solve for x. That's going to give me negative 2/3 as one answer, and then positive 2/3 as the other answer. Okay, we're just going to try a couple more here. Okay, again, the main difference with these problems versus the previous video is these are now equations. Okay, this doesn't seem like there is a GCF. This definitely has 3 terms in it. There's a trinomial. I'm noting that the lead coefficient is a 1, so it feels like it's this type E here. If you remember, that's the type where we make an X puzzle, and we can start by just drawing 2 sets of parentheses with an X at the beginning of each. Okay, my X puzzle will have -6 in the top, +1 in the bottom. I need 2 numbers that are going to multiply to be a -6, but I need them to add together to be a +1. Those 2 numbers would be a +3 and a -2. Okay, keep in mind this was an equation, so you want to put the equals 0 at the end. Okay, and the whole reason, if you remember, that we are setting each of the factors equal to 0 is because we're saying we're multiplying 2 numbers together. X plus 3 represents a number, X minus 2 represents a number. We are multiplying these together. We're getting 0 as our answer. So one of these 2 numbers has to be 0, or they could both be 0. Okay, and so we're going through, and that's why we're setting each one or the other, or both have to represent a 0. Okay, answers are -3 and +2. Okay, and then the last one here, again, I'm going to check for a GCF. It looks like there's a 4 that we could probably remove from each of these. So I'm going to divide 256 by 4. That leaves me with a 64. Okay, I'm going to look at what type of problem I think this could possibly be. I see a sum here. Maybe it's a sum of 2 cubes. Let's see. My exponent on the variable is a 3. That's divisible by 3. That means x cubed is a perfect cube. If you're unsure whether 64 is a perfect cube, you could take the cubic root of that using the math button, option 4. It is. Okay, so this is a sum of 2 cubes. I want to keep the 4 in front. I'm going to go ahead and kind of create a space here for, I'm going to go ahead and highlight this is kind of my answer, should be in that format. Okay, if you remember, this is when we use the acronym SOAP. Okay, S stood for same, so I want to use that same sign plus. O stood for opposite. I'm going to switch to a minus, and the AP is always positive at the end. Okay. Then I'm going to take the cubic root of the first term. Cubic root of x cubed is x. I'm going to call that my A. Then I'm going to take the cubic root of the last term. Cubic root of 64 is 4. I'm going to call that B. And then I'm going to fill in the binomial A and B. So this will be x and 4. Okay. Then we fill in a squared in the front, b squared in the back. That would be an x squared here and a 16 there. And in the middle, I'm multiplying a and b together. So that would be a 4x. Okay, now remember this was an equation, so we're needing to set factors that have variables in them equal to 0. Now I do have 3 factors here. However, the first factor has no variable, and if you recall, the second factor, even though there are variables in it, we said that you're never going to be able to factor this down further. So that trinomial, it's not going to produce an answer. You're only going to grab that binomial piece, simply set that equal to 0. The answer is x equals 4. However, you have to show all this factoring process because the directions are asking you to solve this by factoring, okay, using the factoring technique. Answer is x equals 4. Okay, your assignment is worksheet 5.5b, and this was just a little bit of a review and really just making these problems